Continuing our discussion of tables and graphs, we had already talked about bar graphs and how bar graphs can be misleading. Another common graph used is a line graph. So let's look at an example of how we can create a line graph. If you look at the information up here, what this represents is obviously the years, and this represents population. And it's actually the population of people over, so I'm going to say greater than 65 in the US. Okay? So what we want to do is create a line graph. And the reason we want to create a line graph, like we talked about before, there are many different ways to display data. Bar graphs, pie graphs, stem and leaf plots, histograms, all of those. But probably the two most popular are bar graphs and line graphs. And we like to use line graphs when we're talking about time, meaning years or minutes or hours or days or whatever, because they can show us trends over time. So if we were going to create a line graph of this, what we want to do is we want to put our years on our x-axis. So I'm just going to write this as 1960, 1970, 1980, 1990, and 2000. Notice I don't have to start from year 0. Again, we call our x-axis our independent variable, and we'll talk more about that later. Anyway, we can just use the data we're given. But if we're talking about our y-axis, remember, this is our population. Oh, and I should tell you one more thing. It's in millions. Meaning, this is 17.4 million. Now, when we go to create this line graph, you want to take a look at your least and greatest data values. Our least is 17.4 and our greatest is 39. Of course, million. We don't necessarily, again, have to start from 0, but on the y-axis we really should put a bar break in. Okay? And that means that we've compressed some data. Again, you don't necessarily need one on the x-axis. You can put one, but again, that's independent. So if we're looking, we start at 17.4, maybe we want to start at 15 million, 20, 25 million, 30, 35 million, and this is 45 million. Okay? And I guess this is the years. It's important to label because that allows us to know what's going on in the graph without having the table here. And this is population. And then it's important to put it's in millions because we have more than 15 people over the age of 65 in the United States. Okay, so again, we just plot these points. Here's 1960, 17.4. Oh, this is 20, so about in here. In 1970, 21.4 would be about in here. 1980, 27.8. Oops, I should move that down a little bit. 1990, we had 34.3. And in 2000, it was at 39. So again, you guys, you can notice that our data does not lie on a perfect line. If we were to draw a line through this, it wouldn't be perfect, but it's pretty close, and we can definitely see a trend over time. With line graphs, you really should probably connect the dots, if we can say that, because it shows us what's happening. But it's not a continuous path. We can see that every time we're going up, but it's not necessarily by the same amount. The great thing about a graph as compared to a table is we can tell different things about it. When was the population or the number of 65-year-olds plus the United States, when did it when did it increase the least? So they're always increasing, but when did it increase the least? Well, from 1960 to 1970, it doesn't look like it went up very much, even though it still went up. So we were able to see this from the graph. The least increase occurred here. But we can tell from our graph, we can take different pieces of information out of it that might be easier to see than what's in the table. So again, with line graphs, they're good for showing values or changes in data over time. And it's important to be careful to label our axes so we know what we're talking about. You can make a beautiful graph, but if you don't label the axes, who knows what you're talking about. Okay, so again, line graphs are good to show data over time.